If you're enjoying the content, please consider subscribing and liking the video. It truly helps the channel grow. It is November 7th, 1867, in Warsaw, the capital of Poland, but on the maps of the time it is part of the Russian Empire. The Polish language is restricted in schools, the flag cannot be flown, and patriotic songs are watched with suspicion. In a small apartment above a school for boys, a baby girl is born to Vladislav and Bronislawa Skłodowski. They name her Maria. Later, the world will know her as Marie Curie, but in this moment, she is simply the youngest of 5 children in a family that believes fiercely in education and in a Poland that might one day be free. Her father teaches mathematics and physics. Her mother runs a private girls' school. The home is filled with books, maps, and the quiet seriousness of parents who have seen hopes crushed but have not given up. When Maria is still very young, political pressures cost her father his job. The family's finances shrink. They rent out rooms to students. Illness enters the picture as well. Two of Maria's siblings die when she is a child, and her mother, suffering from tuberculosis, grows weaker each year. These losses carve deep lines inside the sensitive girl. She learns early that life can be short, and that strength may be found in work and knowledge. Maria is an excellent student. At school, she loves physics and mathematics, quickly rising to the top of her class. But as a girl in Russian-ruled Poland during the late 19th century, her possibilities are sharply limited. The universities are closed to women. The language of instruction is Russian, not Polish. Still, she studies in secret. She joins a group known as the Flying University, an underground network of teachers and students who meet in apartments to study banned subjects in Polish. It is risky, but it keeps alive both culture and ambition. In smoky rooms and whispered lectures, Maria absorbs ideas about science, liberty, and the power of the mind. She also learns about sacrifice. Her older sister Bronia dreams of becoming a doctor, an almost impossible goal for a Polish woman of their time. The family cannot afford to send both girls abroad. Maria and Bronia make a pact. Maria will work as a governess, sending money to help Bronia study medicine in Paris. Later, when Bronia is established, she will help Maria follow. For several years, Maria lives in the countryside, tutoring children of wealthier families. She is lonely, cut off from laboratories and libraries, but in the evenings she devours physics and chemistry textbooks. She studies formulas by candlelight, filling notebooks with calculations. The dream of a real university burns steadily. In 1891, at the age of 24, she finally makes her move. With just enough money for a train ticket and the promise of a sofa in Bronia's small Paris apartment, Maria arrives in France. Paris at the time is alive with ideas. Art, music, politics, and science all mix in crowded streets and cafes. At the Sorbonne, the University of Paris, she enrolls under the name Marie Sklodowska. The lecture halls are cold, the benches hard, and the exams brutal. She is one of only a handful of women studying advanced physics and mathematics. Life is difficult. Marie often wears all her clothes at once to stay warm in her unheated room. Sometimes she is so poor that she eats only bread and tea, fainting from hunger but refusing to slow down. She studies late into the night, her lamp shining over notebooks filled with equations. In the summer, she tutors or teaches to earn small sums. The effort pays off. In 1893, she finishes first in her class in physics. A year later, she earns a degree in mathematics. For a girl who once had no legal path to university at all, the achievement is astonishing. But for Marie, it is just the beginning. She now needs a research topic and a laboratory. A colleague suggests she meet a quiet, intense physicist named Pierre Curie, who has been doing important work on crystals and magnetism. Pierre is in his mid-30s, modest, and completely absorbed in his experiments. He and his brother had discovered the phenomenon known as the Curie point, the temperature at which certain materials lose their permanent magnetism. When Marie comes to his lab seeking instruments for measurements, he's impressed by her seriousness. He offers space and equipment. They begin to collaborate. Out of this partnership grows something deeper. They talk for hours about science, ideas, and the nature of reality. They take long walks through Paris, heads bent together, oblivious to the noise around them. Pierre proposes marriage. At first, Marie hesitates. She still thinks of returning to Poland to build scientific education there. But opportunities back home are uncertain, and in Paris, she has both a partner and a path. In 1895, she marries Pierre Curie. They spend their honeymoon on bicycles, pedaling through the French countryside, talking not about fashion or parties, but about molecules, forces, and the promise of X-rays, which have just been discovered. When it is time for Marie to choose a research subject for her doctoral thesis, she looks toward the mysterious new phenomena that are shaking physics. In 1895, Wilhelm Röntgen discovered X-rays. In 1896, Henri Becquerel found that uranium salts emit invisible rays that fog photographic plates even in darkness. The source of this energy is unknown. Marie decides to investigate these rays systematically. She begins by taking careful measurements. Using an electrometer that Pierre and his brother had designed, she can detect tiny electric currents produced when the mysterious rays ionize air. She discovers that the radiation depends on the amount of uranium present, not on its chemical form. This suggests that the effect is linked to the atom itself, not to how it is arranged in molecules. Quietly, in an underheated shed that passes for a lab, she writes in her notebook, "This is a property of the atom." It is a revolutionary idea. At a time when many scientists still imagine atoms as unchangeable, solid beads, Marie is seeing that atoms can emit energy, that they are not eternal and unbreakable. She coins a new term for the phenomenon, radioactivity. Her measurements also reveal something unexpected. Certain samples of a mineral called pitchblende, which contains uranium, are more radioactive than pure uranium itself. This means that pitchblende must include small amounts of some unknown, even more intensely radioactive substances. Marie and Pierre decide to search for them. The hunt will dominate their lives for years. They work in a leaky wooden shed behind the School of Physics and Chemistry, a space that Pierre describes as more like a stable than a laboratory. In winter, it is freezing. In summer, the air is heavy with fumes. They simmer enormous iron cauldrons of crushed pitchblende and acid, stirring with iron rods, then cool, crystallize, and test each fraction for radioactivity. The labor is brutal. They move tons of material, boiling, filtering, and measuring. Day after day, Marie walks from vat to table, from table to instrument, recording slight increases in the strength of the rays. Slowly, her persistence is rewarded. In 1898, the Curies announced the discovery of a new element, which they named polonium, in honor of Marie's native Poland. A few months later, they identify a second new element, far more radioactive, radium. To isolate even a tiny amount of pure radium salt, they must process enormous quantities of ore. The work is backbreaking and dangerous. Neither they nor anyone else yet fully understands the health risks of prolonged exposure to radiation. Marie handles glowing test tubes with bare hands, noting only that she feels tired and that her fingers sometimes burn. By 1902, after 4 years of work in the shed, Marie finally isolates a fraction of a gram of radium chloride from several tons of pitchblende. The pale substance glows faintly in the dark. Its rays can burn skin, destroy tumors, fog photographic plates, and cause air to conduct electricity. The energy streaming out of it seems endless. Journalists speak of the Curie's magic, but in Marie's mind it is not magic at all. It is careful measurement, patient separation, and the logic of chemistry applied over and over again. The scientific world takes notice. In 1903, the Nobel Prize in Physics is awarded jointly to Henri Becquerel and to Pierre and Marie Curie for their work on radioactivity. At first, the committee considered honoring only Becquerel and Pierre. A sympathetic member points out that Marie's contribution is equal, and that leaving her out would be a mistake. Her name is added. Marie Curie thus becomes the first woman ever to receive a Nobel Prize. Fame arrives suddenly. Reporters knock on the Curie's door. Scientific societies invite them to speak. Universities that once ignored her now send flattering letters. Marie, who prefers plain clothes and quiet work, feels uncomfortable in the spotlight. She would rather return to her flasks and instruments. She and Pierre refuse many honors and decline to patent their radium extraction process, believing that scientific knowledge should be shared freely for the good of humanity. This generosity will have financial consequences later, but at the time it seems self-evident to them. Their personal life is modest. They live in a simple apartment and ride bicycles through Paris with their young daughters, Erin and Eve. They read, play music, and talk about science. Marie balances her role as mother with her role as researcher, sometimes bringing papers to correct while watching the children. The glow of radium samples in the bedroom drawer, which they find beautiful, becomes a quiet hazard they do not yet understand. In 1906, tragedy strikes. On a rainy April day, Pierre Curie is walking across the Rue Dauphine near the Pont Neuf in Paris. As he steps into the street, horse-drawn carriage suddenly appears. Slippery cobblestones, a distracted driver, a moment of misjudgment. Pierre slips, falls under the heavy wheels, and is killed instantly. He is 46 years old. The news shocks Paris and the scientific world. For Marie, it is a shattering blow. She loses not only her husband, but her closest scientific partner, the man who walked beside her through the cold shed and the roaring columns of data. For days, she is numb with grief. She writes in her diary, addressing Pierre directly, as if he might still hear. Friends worry that she will be crushed by sorrow. But slowly, driven by a sense of duty both to her children and to their shared work, she returns to the laboratory. The Sorbonne offers her Pierre's chair in physics. In 1906, she becomes the first woman to teach there. On the day of her inaugural lecture, the hall is packed. Some come to see a historic event. Others simply come to stare at the woman who has dared to step into a role traditionally held by men. She begins her lecture at the exact point where Pierre left off, continuing his sentence in her own voice. For a moment, it is as if he has not vanished, but simply changed speakers. Work becomes her anchor. She pushes forward in the study of radium and its compounds. She publishes a massive doctoral thesis in 1903, one of the most important in the history of science, detailing the properties of radioactive substances. In 1911, she receives a second Nobel Prize, this time in chemistry, for the isolation of pure radium and for defining the concept of radioactivity with precision. She becomes the first person, and still one of very few, to win Nobel Prizes in two different scientific fields. The honor is immense, but it comes in the midst of emotional turmoil. That same year, she is the target of a scandal in the French press. After Pierre's death, she had formed a close relationship with a fellow scientist, Paul Langevin, who was separated but still legally married. Their private letters are stolen and published. Newspapers portray her as a foreigner breaking up a French family. Crowds gather outside her home, shouting. Stones are thrown at her windows. She is advised not to attend the Nobel ceremony in Stockholm because of the controversy. She goes anyway. On stage, she is pale but steady. She knows that her work stands independent of gossip. The storm eventually passes, but the episode reveals both the hostility she faced as a woman and the emotional cost of being a symbol. Through it all, Marie holds to a simple internal rule. In science, we must be interested in things, not in persons. She refuses to let personal attacks derail her commitment to research and teaching. In 1914, a new chapter begins. The University of Paris and the Pasteur Institute create the Radium Institute, a center devoted to research on radioactivity and its medical uses, and Marie is asked to lead the physics and chemistry section. Almost at once, World War I erupts. Instead of retreating into pure research, she looks for a way to help. X-rays can reveal bullets and fractures hidden inside the body, but machines are rare and poorly distributed. Marie designs mobile radiology units, cars fitted with X-ray tubes, generators, and darkrooms that can be driven close to the front. She learns to operate the equipment herself, then trains other women to do the same. These little Curies, as the vehicles come to be called, travel from hospital to hospital. In muddy fields and crowded tents, wounded soldiers lie beneath the flicker of the tubes while surgeons study the plates that Marie and her team quickly develop. It is estimated that well over 1 million men are examined in this way. The conditions are crude and the radiation protection almost non-existent, but the impact is enormous. Operations become safer, fewer limbs are amputated, and countless lives are saved. After the war, Marie returns to the Radium Institute, now with a new sense of purpose. She is convinced that radioactivity can be harnessed to treat cancer and other diseases, but she also knows it must be handled with care. Her own health has begun to show signs of damage. She experiences fatigue, pain, and failing eyesight. Yet she continues to travel, lecture, and raise funds for research. In 1921, she makes a celebrated trip to the United States, welcomed as a scientific hero. American women's groups organize a campaign to raise money to buy her 1 gram of radium for her institute, an element that at the time is more valuable than gold. She receives it in a special lead-line container from President Warren G. Harding at the White House, accepting not for herself but for science. Back in Paris, she devotes herself to building a strong team at the Radium Institute. Young researchers from around the world come to study under her. Among them is her own daughter Erin, who will later share a Nobel Prize for the discovery of artificial radioactivity. Marie insists on high standards and modest behavior. She dislikes personal publicity and refuses to have her image used in advertisements. When companies try to use her name to sell beauty creams or quack radium cures, she protests. She understands, with growing sorrow, that the public fascination with radium's glow can be dangerous. Some early industrial uses, such as radium-painted watch dials, are already causing illness among workers who ingest radioactive material. The same rays that can destroy tumors can also damage healthy tissue and bone marrow. In the last decade of her life, Marie Curie's health declined steadily. Years of exposure to X-rays and to unshielded radioactive materials have taken a toll on her bone marrow and immune system. She develops aplastic anemia, a condition in which the body can no longer produce enough blood cells. She grows weaker, but still works as much as she can, reviewing papers, advising students, and planning future experiments. She wears thick glasses to read, her vision clouded by cataracts. She rarely complains. In July 1934, she travels to a sanatorium in Saint-Célimaz in the French Alps, hoping that the mountain air will help her recover. It does not. On July 4, 1934, at the age of 66, Marie Curie dies. The medical report cites pernicious anemia caused by long-term exposure to radiation. Even in death, radioactivity surrounds her. Her papers, notebooks, and even her cookbooks are so contaminated that they must be stored in lead-lined boxes. Researchers who consult them today must wear protective clothing and sign waivers. It is a strange kind of immortality. Her legacy, however, is anything but toxic. She changed the course of science in profound ways. She showed that atoms are not indivisible, but dynamic sources of energy. Her careful measurements laid the foundation for nuclear physics and for our understanding of radioactive decay. The elements she discovered, polonium and radium, opened new paths in both physics and medicine. She demonstrated that a woman, even one coming from a poor, occupied country, could rise to the highest levels of scientific achievement through determination and talent. She also reshaped how scientists work. Her decision not to patent the radium extraction process encouraged open sharing of knowledge. Her leadership at the Radium Institute created a model for interdisciplinary research centers where physicists, chemists, and doctors collaborate. Many of the great discoveries of 20th century nuclear science, including work that eventually led to the understanding of nuclear fission, grew out of the environment she built. Beyond the laboratory, Marie Curie's life offers a powerful story about character. She faced discrimination as a woman, suspicion as a foreigner, and attacks from a scandal-hungry press. She endured poverty, grief, and the gradual breakdown of her own body caused by the very phenomenon she studied. Yet she never allowed bitterness to define her. She found joy in curiosity, in teaching, and in the quiet logic of experiments. She once said, "Life is not easy for any of us. But what of that? We must have perseverance and above all confidence in ourselves." Imagine, for a moment, one of those many nights in the rough shed where it all began. The city outside is quiet. Inside, a vat of pitch blende boils, the air white with steam. Marie moves between cauldron and table, testing each new fraction with electrometer, watching the needle twitch. Her back aches, her hands are split from acid, but she notes every reading with calm precision. There is no audience and no guarantee, only work, patience, and the feeling that nature is whispering a secret that she is determined to hear. Decades later, in hospital tents during the First World War, the scene has changed, but her purpose has not. A wounded soldier lies under an X-ray tube. Marie adjusts the settings and studies the ghostly image that appears on the plate, showing surgeons exactly where to operate. In those dim rooms, she turns invisible rays into maps that help bring men home. The same curiosity that once chased a faint glow from radium now serves as a tool of mercy. Today, when doctors use radiation to diagnose and treat disease, when scientists study nuclear reactions in reactors and in stars, they build on foundations she helped lay. Her life shows that science is not only flashes of genius, but also long days of careful labor, of stirring vats, recording numbers, and trusting that understanding will grow. Marie Curie did not seek fame, she sought to know. In doing so, she illuminated hidden structures of the universe and left behind a simple, enduring message. Nothing in life is to be feared. is only to be understood. For the girl who once studied in secret and became one of history's greatest scientists, that belief was not just advice. It was the current that carried her entire life.